Okay. All right. So thank you all for coming. I just want to give you a quick introduction of me and the rest of my team. So my name is Stephanie Dutra. I'm a sophomore at the University of Illinois studying aerospace engineering. And I will be leading this presentation. And my co-host is Devanshi. Devanshi, would you like to introduce yourself?
Okay, hi guys. I'm Devanshi. I'm also a sophomore studying aerospace engineering at the University of Illinois. I'm Stephanie's co-host. I'm here. I'm going to teach y'all how to make a paper rocket. That's all for now. Nathan?
Yeah, hi everyone. My name is Nathan Finkelstein. I'm a freshman at the University of Illinois studying nuclear engineering. Yeah, and today I'm just gonna be making sure that you guys, everything works fine technologically, and that you guys are, all of your questions are getting asked and stuff like that. And then Anshuk.
Hey guys, my name is Anshuk. I'm a sophomore in aerospace engineering. I also study at the University of Illinois. And yeah, I think this is going to be a lot of fun today.
All right, so that is our team. So thank you again all for coming. Before we get started, I just want to go over Zoom stuff really quickly. So during the presentation, please be sure to be on mute unless you're asking a question or I ask you guys to unmute. So just be sure to do that, and we might tell you to mute also if you're not on mute. And then also for those of you who have your videos on, sometimes I'll ask for like a thumbs up or something, and you can just give me a thumbs up in the video. But if you don't have your video on, it'd be great if you could use the thumbs up reaction, which is, I believe, in the bottom right-hand corner as I put on that slide. It's the little smiley face, and then you can just hit thumbs up. So I just wanted, like everyone's doing right now. So great job, guys. Yeah, so let's get started. Okay. So before I start with this video, I just want to ask, what does everyone know about rockets? Can someone tell me what they know about rockets? Can you like put up your hand or raise your hand with the raise hand function? We have any volunteers? Does anyone know anything about a rocket? Oh, Porter. Can you unmute and tell me about what you know about rockets?
Well, I know that they're used to launch people into space. They use rocket engines to get people there, and you disconnect the bottom part of them when they get into space so we don't have extra weight. Yeah,
for sure. Liam, do you want to unmute and tell me what you know about rockets?
So I actually play Kerbal Space Program, and I know some things about like how the engines work and how things decouple. Cool. And I know how some model rockets work because I launched my own model rocket a few times until it landed in a tree or something.
That's so fun. Does anyone else have anything they want to add about what they know about rockets? You can like raise your hand or use the raise hand function.
Clara? I see Clara's got a question. Unmute yourself if you want to ask it.
That they come from a launch pad by my great grandma's house.
What state?
In Florida.
Oh, cool. Wow, that's so fun. Have you ever seen one launch, Clara?
Yes.
That's really cool. Wow, I'm jealous. All right, does anyone else have anything they want to share about what they know about rockets? Okay, if not, I think I will move on to show you guys a rocket launching. So if you didn't watch this, I think this was a couple months back, but this is the historic Falcon 9 flight, which was NASA and SpaceX. Have any of you guys, did you guys watch that live when it happened?
Me?
Yeah.
What?
Yeah, it was really cool.
Yep.
Yeah, so
We
I'm gonna play that video for you guys. Let me make sure my computer sound is on, but it's just a really cool video. Share computer sound. Okay. It should be good.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. Liftoff of the Falcon 9 and Crew Dragon. Go NASA, go NASA, go SpaceX. Godspeed, Bob and Doug.
America has launched. And so rises a new era of American spaceflight, and with it the ambitions of a new generation continuing the dream. 20 seconds into flight, stage 1 propulsion is nominal.
Yeah, so that's what a rocket launch looks like, and it's really, really cool. And today we're going to be teaching you guys some more about rockets and the different parts of rockets, and like how, I guess how that's even possible, you know, to like get something all the way into space. We're just kind of break apart a rocket and talk about the different parts of it. So before I continue on to that, do any of you guys know what rockets are useful for? Like, why do we have rockets? Why do we use them? Why do we send them to space? Does anyone have any ideas for that? Tanuja, if that's how you pronounce your name, you can unmute and let me know.
Ptolemy.
Oh, I think, Tanuja, I think your microphone isn't working.
Ptolemy.
Hi, Sarah, what's up?
They use them to go and explore the space.
Yeah, no, so space exploration is like a big reason we have rockets. Does anyone else have any other ideas?
Liam has his hand
So
up.
in the chat, Santi says to explore other planets.
Yeah, no, for sure. Does anyone else have any other ideas? Also, Tanuja, if your microphone isn't working, maybe Nathan can help you out with that in the chat. So you can message him and we can figure out if it's good to go. Christy, what do you have to share? Christy, you can unmute and let me know.
To launch satellites.
To launch satellites, yeah, for sure. Yes, cool. So, also, can one of my co-hosts please, actually, wait, I figured it out. Never mind, everything's good. Okay, so yeah, those are all a bunch of reasons why we do have rockets and when we have them and send them to space. Some other reasons are to carry like science experiments, so you can do science experiments in space, and also because people are in space and people need things and we have to get them to them, and you know there's no store in space, so just pick stuff up. So we have the International Space Station, which is where we do have like astronauts who are in space doing stuff like science experiments up there. So for them to get there, they have to take a rocket up there. So those are a few of the fun reasons. And I'm also, let me see. I think someone annotated it. I need to, but I'm having trouble doing that. So I'm just gonna move on. If one of my co-hosts could figure out how to clear the annotations on the screen, I disabled it. But if you could clear it, that'd be great. Also, can you make sure everyone's on mute right now? Because I think I hear my echo. But good. So moving on, we're gonna talk about the different parts of a rocket now. So these are like some kind of scary diagrams, but I'll just like break it down and then I'll show you a real life rocket and where these things are on that. So as you can see over here, let me start annotating it. Oh, here, I figured it out. Okay. So this part right here is the nose cone. It's the kind of pointy part at the top of the rocket. It helps with aerodynamics, which are basically just qualities that help a rocket fly better through the air. And then we have this part where this is like the body tube that would be holding, you know, like fuel and like also like science experiments and stuff like that. And then we have these fins that help with also having it travel through space, just kind of navigate the air and stuff. And that's on like an actual rocket. I also put a comparison for a model rocket here on the right, which I know some of you guys, I've heard you've launched model rockets, which is really cool. So, I mean, obviously the setup is going to be kind of different than a rocket launched by NASA, but the same structural components are there. You know, you have a nose cone, you have fins, you have an engine, and you have like in model rockets we have like parachutes and stuff like that. So yeah, now I'm going to show you a really cool like actual real life rocket I have with me. So I just close the screen share so you can hopefully see me as the main thing if you have Zoom on speaker view. So I am going to be showing you an actual rocket I have with me that we built for our club. So this is the upper half of the rocket. As you can see, this is like the nose cone portion, and then this is the upper half of like the airframe. Right now it's hollow, but usually, you know, you would have a lot of stuff in here like electronics and stuff. And then I also have the bottom half of the rocket. So here we have the fins. You would have like the engine here, and then this is the upper half. And again, these actually, right now it's in two parts. And I believe someone might have mentioned it, but rockets like can split at the top. Like high-powered rockets, model rockets, not the, and also like NASA rockets and stuff. Like we split them at a certain point. For rockets like these, which are club launches, we split them at the top of its height so it can come down, so the parachutes can come out. Basically, anyways, there's two parts, and these actually fit together with what we call a coupler. So this is a smaller portion, like the diameter of the cylinder is a bit smaller, so it just fits in here, and then this part fits onto it, and then you have like a whole rocket that is almost taller than me at this point. Kind of struggling to fit it right now, but I can show you guys later because I don't want to take up too much time with me struggling with this. Let me see if I can get it. There we go. Okay. I just want to show you guys the whole rocket and like how it fits together and how tall it is. So there we go. Yeah, so this is the entire rocket. As you can see, it fits together. And then, yeah, so this is what it actually looks like. So I just wanted to show you guys like a real life example of what I just showed on that slide. So does anyone have any questions about the different parts of a rocket? You can raise your hand, or you can use the raise hand function just to let me know what's up. Clara, what do you have? What questions do you have? You can unmute Clara. Wow, you have a rocket with you.
What do the fins do?
What do the fins do? That's a good question. So in these cases, so the fins, I think one of the main reasons is it kind of helps with, again, the kind of big word I brought up earlier, which is aerodynamics. And that's just kind of how it helps, like it's the features kind of the rocket. So like the fins, it helps it travel through the air in like the most efficient way without it like getting, I guess, messed up at all. It's just the most streamlined kind of thing for the rocket for it to travel well. There's kind of a lot of complicated reasons. But if anyone else on my team like wants to explain that better, you can let me know. But that's kind of like sorry, yeah?
Yeah. Who asked this question? Wait, I'm sorry.
Who asked the question I answered, or?
Yeah.
I think Yesley, I believe.
Clara.
Oh, was it Clara? Oh, I'm sorry. Yes, Clara did ask that question.
Hello. Clara, have you ever been swimming?
Clara, you can unmute.
Please unmute.
Clara? Okay, I think she's unmuted now.
Yes.
All right, so you know how when you go swimming, if you kind of make yourself into like a tighter object with your hands in front of you and you have them all like, let me turn on my video. You have them like positioned and stuff, it helps you go through the water more quickly.
Mm-hmm.
That's kind of what the fins do. They help the rocket go through the air in a way that is the least, it's like, well, you guys know what efficient means, right? Yeah, it's the most efficient way for the rocket to move through the air. So they really just help the rocket go all smooth like and let it blast off more easily.
I have a know something.
Yes, do you have a question? Or does someone have a question? Or
It's my brother.
okay, does your brother have a question or about the parts of a rocket or anything?
It's so the fender for it so it can stand up.
Well, I mean, the rocket, when we're launching it, at least, it's going to be going through the air, right? So there's nothing really for it to stand up on. But I mean, yes, in that if it's stationary, the fins might help it stand up. But we mostly build rockets for the properties they need when they're flying through the air and not when they're on the ground. But yeah.
The fin question was pretty good.
All right, so I'm gonna move on. If you guys have any more questions, you can put them in the chat, and I'm gonna ask everyone just to go back on mute for now. Yeah, so I know there were some questions about like about the rocket flying and stuff. I'm gonna show a video really soon of actually like a very similar rocket to the one I showed you guys earlier of that flying. But first, I want to talk a little bit about the path of flight for a rocket. So as you can see here, the rocket, this is where it's being launched, and then it goes up and up and up and up. And at this point right here at the top, that's its highest point in its path of flight. And that's what we call the apogee. So that's just kind of like a fun rocket scientist word that we use to explain what that is. So I'm actually going to have you guys try to guess where the apogee is in the video I show you guys soon. But let me finish kind of explaining this first. So one thing I want to ask is, how many of you guys know what gravity is and what gravity does? Does anyone know and can explain it to me? Does anyone raise their hand? Christy, do you want to unmute and let me know what gravity does?
It pulls stuff back to Earth.
Yeah. So yeah, for sure. Yeah, so like if you jumped right now, you don't fly off into space, right? There's a force, gravity, that's pulling you down to Earth. So kind of what that's doing with the rocket here is that our rocket, when we first launch it, our engine's burning, right? So that's going to be pushing our rocket upwards. So we have a force that's going up. But this entire time, gravity is still pulling it down. Like I'm sitting here right now because gravity is pulling me down and not letting me fly into space, right? So gravity is always going to be acting on the rocket. The difference is at the beginning, at this point in the flight, it's being pushed up way, way more. But at the top of its path of flight, which is the apogee, this is when the rocket pretty much burns out. So it doesn't have that force upward anymore. So now it just has that force of gravity pulling it downward. So that's why it starts to go down. So that's kind of explains the path of flight for a rocket. And this is at the apogee is also the point where the parachute comes out. So, you know, we don't want our rocket to get hurt. We need to slow down the speed of the rocket because if it comes down really fast, it's going to crash a lot worse than if it came down really slowly, right? So yeah, those are like the basic parts of the path of flight. Liam, do you have something you want to add? You can unmute and let me know. I see your hand is raised. Not, I'm going to move on. Okay, cool. So now, oh, here you can see the what the path of flight for the rocket is here. Sorry if you can hear the background noise. Okay, so how do we put this all together? So now I'm going to be showing you guys kind of talking about actual rocket videos and stuff like that. But first, I just want to go over one thing, which is the different types of propellant for like a rocket and rocket. So I don't know if you guys watched it yet, but we posted a video for hybrid, and that was the non-live presentation. And they talk about a hybrid engine, which is the one pictured here on the right. And there's also solid rocket engines, which is probably what most of you, if you have dealt with model rockets before, have used. And there's also like liquid propellant rockets. So I do want to just let you guys know to if you haven't already watched the hybrid presentation, to do that. And Nathan will put that link in the chat just so you guys can watch it later if you haven't already. But did anyone already watch it and want to tell me what they learned? Has anyone gotten to see that video yet? If not, it's totally okay. I just wanted to know. Doesn't look like people have, so definitely check out that link, save it for later, and watch that because it's really cool, and by another team in our club. So Nathan put it in the chat, so you can watch that after our presentation. Yeah, so I just wanted to mention that. And then I kind of already talked about this, but this is so that's how it's going up. The engine's burning, and then on the way down, again we have like parachutes. So that's kind of similar to, you know, if someone's like skydiving at a certain point, they want to slow down their speed. They're gonna open the parachute so they can fall down at a much slower speed so they don't get hurt. And here they're like skydiving or gliding or something. So it's kind of analogous to how a rocket would work. So now this is the how does this actually work part. So I'm going to play a video of a rocket launching. And if you guys remember the word apogee, which is again the highest point in the path of flight, I want you guys to guess when that's going to happen while you're watching the video. So I'm going to play the video, and when you think the rocket hits apogee, I want you to give me a thumbs up or a thumbs up reaction. Just see if you guys can figure it out from what you know about the apogee. So I'm going to play this video now, if it lets me. Okay, cool. Okay. Should be playing now. Yes, so now the engine's burning, it's taking off. So give me a thumbs up when you think it hits the apogee. Yeah, great job. So the point at which it hits the apogee was about right here. So if you noticed earlier, you could tell like here it was going up and things were still getting smaller. But at the point of the apogee is kind of where it pauses for a little bit, because that's when the speed like kind of hit zero and then it starts to come down. So this is the point where the parachutes are released. You can see here, there's actually two parachutes. There's a smaller parachute that's released first to just like slow down the speed. And then there's a bigger one released later to like make sure everything lands super safely. But yeah, I'll just let this video play through for a little bit. Also, the rocket is spinning a lot, so don't look at it if you get dizzy. I know I do sometimes. I just wanted to say that because sometimes these videos can be hard to watch, but they are really cool. Yeah, so this is one of the rockets from a competition within our club that we do. So this is a very similar size to the rocket I showed you guys earlier. So when someone asked, does it fly? If that was talking about the rocket I was showing you guys, it absolutely does. And this is a video of a very similar one doing the same thing. So yeah, this is it landing. You can see here that the rocket actually split into like two parts. So the lower part is at the bottom. And then there's a little parachute here, and I believe probably a parachute above. And yeah, this is just it landing. And that's that video. But I also want to show you guys it from a different angle. So this is a rocket launching from the ground. So as you can see here, that's what it looks like. Pretty cool. Yep. So now, well, first, does anyone have any questions about like anything we just watched? Anything about the parts of the rocket before we get into construction?
It looks like Arush has his hand raised.
All right, can you unmute and let us know your question?
How come the rocket splits into two parts?
Yeah, so for our rockets that we launched, so we have it split into two parts because we need to have the parachute somehow like eject from the rocket and bring it down to safety, right? So we can't have the parachute already hanging out of the rocket before we launch it, because then that would affect like the launch itself. You know, you'd have this weird thing causing a bunch of drag, which is a word I'll explain later. But so the way this works is we want the parachute to come out at the top so it can come down safely. So that's why we have a ejection charge that splits the rock, helps split the rocket into two. And then that's when the parachute comes out. So that's why it splits into two for the rockets that we launch, because we need the parachute to come out is the main reason. Yeah, April, what's your question?
Why
Uh,
do we have this ball?
Why do you have that ball? That is going to be used for a different presentation. So you don't need it for this one.
What did it say?
I'm sorry. Yeah, so the little bouncy ball is going to be for a different presentation. We don't need it for this one. Also, can everyone just mute, because I do hear some background noise. But yeah, don't worry, April, you don't need that for this presentation. You'll find out later what you need that for. Does anyone have any other questions before we get ready?
It looks like Arish still has his question. He's still raising his hand.
Yes, Arish, what's up?
Why is the parrot actually why how does the parachute give it slowly air to land down safely?
Yeah. So I guess so the parachute is this like very large surface area. And you know, so before we have this like really dense rocket, right? It's something that's very, very heavy. And if we don't get that parachute, it's just gonna fall right down, right? But have you ever thrown like a piece of paper and seen how like it never kind of goes where you want to go, or you throw a tissue or something, it kind of floats around. Like it's not dense, it doesn't just fall straight down. It kind of goes down like a lot slower. And that's because of some like different forces that are happening with things called like lift, which is kind of like a confusing thing in physics, but it's basically just a force that's pushing up. And something like a parachute is gonna be this light thing that air is gonna be like pushing up into it. So it should go down like a lot slower than if you drop like a brick, right? Like if you've ever had, I think there was those little toys that were like, I think soldiers with like little parachutes, and they'll float down versus if you're gonna drop a brick, that's obviously gonna be a lot more dense. So I hope that makes sense. The reasons are kind of like high level, so that I hope that helps. Before I take any more questions, I do want to say, make sure you get these materials out. So you're gonna need construction paper, tape, scissors, a straw, and a wooden pencil or some other thing that like a pen that is the same shape as like a wooden pencil. So while I continue to answer questions, just make sure you have all those materials out so we can get started. That's my announcement there. So does anyone else have questions about rocket stuff while people get their materials? Emmy, do you want to unmute?
How far did the I don't know how far did one rocket go? What rocket went farthest?
Do you mean like historically, like what rocket has ever gone the furthest, or
what rocket ever?
Okay, cool. Yeah. Nathan, can you look into that? But also like rockets that go, I guess they go into like space and like orbit and stuff. So that's kind of like, not to say like the max distance, but we haven't like really sent rockets off to like, planets like really far away. That we send like other stuff out there. But yeah, Nathan, can you look into that?
Yeah, for sure. So what I'm finding is that the most like distantly launched human-made aircraft was the Voyager 1, which was launched a couple years ago in 2018, and it went over 13 billion miles away from Earth. So it just hit like Jupiter and Saturn just about. So yeah, these rockets can go anywhere from like the moon to Saturn. So it's kind of crazy, right?
Cool. Okay, does everyone have their materials with them? Does anyone need more time to get these materials out? April? Yeah, what's up?
I have like I don't have all of these like
Sorry, I can't really hear you very well, April. You want to try saying it again or typing
a
it?
little bit of time.
You still need a little bit of time? Okay.
I don't have all the materials.
What don't you have?
I have construction paper
Mm-hmm.
and the straw and I know how to pencil.
Yeah, so the main things you need are like construction paper and tape. If you don't have tape, it will be a little bit more challenging, but we can still make it work. You will need like scissors or something to cut out paper. I guess if you don't have scissors, you could also rip it. And then the straws for launching, it's not for building the actual rocket. And a wooden pencil, you could use anything that is of a similar shape to like a pencil. So I hope that helps.
Like the similar shape to a pencil.
Yeah, that's the straw, right? Yeah. So the way launching works is that the straw is going to be a little bit smaller than your rocket, and that's how it just slides on easily and off. So it's important to build the rocket on something that's not the straw, like on something a little bit bigger, like a pencil, so that it actually slides off of this. So see if you can try to get those materials. Is everyone good to go? Can I start with the construction kind of presentation now? Is everyone good? Okay, I'm gonna start with that then. So this is the super exciting part. We're gonna be building our own rockets. So we are rocket surgeons today. So let me see. Yeah, so the first part, the way we're gonna do this is I'll give this presentation. I'll show you guys how to do this with these photos, but my co-host Devanshi is also going to be doing it live after I explain it, just to help you guys and show you how to do it live. So first, let me just give a quick overview. So for making the body tube, the first thing you're going to do is cut out a rectangular piece of paper, roughly the length of the pencil. The width doesn't matter as much because you're going to be rolling it up. But yeah, so something like this, and then you're going to tape it to form a body tube. So you'll essentially have the cylinder like taped around a pencil. So Devanshi, are you good to go with showing your setup now, or do you need more time? Is she good? I can't tell. Oh, I think she is.
Sorry, switching between different things that are muted.
You're good.
I'm good. Just a quick question. I should be the highlighted screen now because I'm talking very loudly. You guys can all see my paper, pen, scissors, fins. Everything's good?
Looks good to me.
Cool.
Yeah, so you can get started with the body too.
Right. All right. So the first thing, as you guys probably heard Stephanie explain, is that we need to make our body tube. So for that, we recommend that you get a wooden pencil. I don't have a wooden pencil, so I'm going to use a pen. And I'm going to take the cap off. Basically, you want to cut your construction paper so that the length of your pencil is just like around the length of, you know, your paper. You don't want like a full size sheet of paper. Otherwise it's going to be really, really hard to roll and everything. Yeah, a fat pencil actually might be preferred because it'll make it a lot easier to launch your rocket. So what we're going to do first is take, you know, your pencil, marker, whatever you're using, and roll the paper around it until, you know, you finish the paper.
I'm using 2 pencils to make it more thick.
No, definitely don't use 2 pencils. Stick with 1. If you make it too thick, it's not going to work at all. So make sure you just use 1 pencil.
Yeah, it's important for it to have like a cylindrical shape. So I feel like if you do 2 pencils, it might be a bit like rectangular. So 1 pencil is totally fine. I did all of mine with just 1 pencil and they work completely fine. But if you want to experiment with making it thicker, you can do that.
Yeah, mine's pretty thick, honestly. You want to get
like a cylinder looking thing. Where's my camera? Right here. All right. You want it to be like that. You can make it a little thinner as long as it, fits around your pencil. And then you just want to tape it shut. So I have tape. If you don't have tape, you can use glue. It's going to be a little more difficult because glue obviously takes a while to dry, but you could definitely still use glue.
What I was saying, can I tape the pencil onto the paper so it'll be easy to roll up?
So it'll what?
So it'll be easy to roll up.
So don't tape the pencil, the paper onto the pencil, because we're building the rocket on the pencil, but we want to be able to slide it off right after. So don't tape it onto the pencil if you can.
Otherwise the whole rocket will come off.
Yeah, if this was my pencil, after I'm done, I just want to be able to pull it off. So
okay.
You don't need to tape it onto the pencil. Cool. So is anyone having any trouble with this part, or can I move on to the next step?
Yes. I'm having a little bit trouble.
Okay, what's up?
I can't roll it up that well.
Okay. So, Devanshi, do you want to show that again, maybe? Or I might also do that.
Okay, I have another piece of paper.
Okay. Yeah, you don't need to tape it, just so.
Guys, everything is fine. Things are falling, but everything is fine. Basically someone's raising their hand. I'm just gonna focus on this for now. I will get back to you. I don't know what's happening over there. You want to kind of clip your hands really close to it at the front, and then make sure that you get this first part rolled really well, really, really tight around the pencil. And then the rest of the rolling should kind of just be really easy. Is there a specific thing that you're having trouble with in the rolling process?
It looked like Porter had his hand raised. Porter, do you still have a question?
Does it matter if the pencil keeps falling out of the paper?
It's completely fine.
Yeah.
Yeah, because the pencil is not going to be like a final part of your rocket. It's literally just so that when you roll up your tube, it's like cylindrical, because you don't want it to be like a square or also like smushed. So
all right,
that's literally the only reason. The pencil does not matter after this, so you'll be okay.
What happened?
Yeah. I just want to say, I just sent a document into the chat that's kind of like a guide on how to do this, just in case you're having trouble and we move on. One thing to know is we're going to teach you how to do the fins in a different way, but if you want to even like follow along and do this at a different time, I just wanted to give you guys that guide. So
is this supposed to be like this?
I'm trying to find your video. Yeah, no, that should be fine.
So do I just tape it now?
Yeah, just tape it. Yeah. Okay. So I'm going to assume that most people have kind of finished up the first part, but if you haven't, it's okay. You can keep working on that. I just want to show the next step for those who have. So the next step, I already have fins on my rocket here, but you don't have to. So the next step is kind of to pinch the paper around the tip of a pencil so that it becomes kind of like a cone. If you don't have it on a pencil with like a wooden tip, that's fine. Just kind of squish it and twist it into a cone shape, and then you can tape that up. And Devanshi is going to show how to do that now also. So I'll stop sharing.
Hello. Returning to you with this weird cone. So if you have a wooden pencil, you can basically just, can you see this? Put it in and then squish it around here to make a nose cone. But if you don't, you can just get rid of whatever you have and like literally squish it with your fingers. I'm clumsy, I'm sorry. Until you get a basic nose cone shape, and then just tape that there. So I will show you, I should have more rockets, but where are they? I have a bunch. This one I squished around a pencil tip, and this one I didn't. As you can see, they basically look exactly the same. So it doesn't really matter if you use a pencil tip or not, as long as you squish this part into like a triangle shape, so it looks like a nose cone.
Mine don't work like that because it's a little thick. Like it doesn't.
Sorry for the cutout. Someone was calling me on my cell phone.
I think Devontae's is also kind of thick, so it is a little bit more challenging to get like a nice cone shape, but you should still be able to squish it together for it to at least be like smaller at the tip.
It doesn't have to be perfect, just as long as it's a little bit squished at the top.
Yeah.
And also, even if you can't really squish with your fingers that well, once you tape it, it kind of turns into like a little pointy nose cone. So it'll be fine. Yeah, I've made a bunch of really thick ones, so I know it's kind of annoying. Stephanie has a bunch of really cute small ones.
Yeah. If you make them a lot thinner, it's a lot easier to deal with it. April, do you have a question? What's up?
I don't really know how to make a cone.
April, I can't hear you. Do you want to speak louder or type in the chat? Okay, thank you. While April's doing that, does anyone else have any more questions, or can I move on to the next part of the presentation?
I think Sai has a question.
Is anyone?
I see a raised hand.
Does Sai? Okay. Sai, what's up? You have a question?
Hi, my name is Ptolemy.
Solomon. Okay. Got you. Solomon?
No, Ptolemy.
Ptolemy with the P. Okay, sorry. Okay.
I don't know how to do the next part. It's kind of hard to do that.
You mean the nose cone part?
I did this one, but I don't know how to do this one.
So kind of just, it's okay if you can't make a perfect cone. But just grab the top and squish it together, and then you can twist it a little bit. And it should just be a little squished and a little twisted. And then you can just wrap it up with tape and it'll be a cone shape. But if it's not perfect, it's okay. This will still work. That again, kind of like how I explained for nose cones earlier, it just kind of helps with its path of flight. So the more like nicely done it is, the better it will fly, but it should still fly regardless. So don't worry too much about that. So I'm gonna go back and I'm gonna just show the next part of the presentation because I do think it's the most I want to give people time to work on it. So now we're going to be doing the fins. So the fins. So there's a bunch of different fin shapes you could do. These are just some examples of some different ones. I did some triangles, some parallelograms, and some trapezoids myself. You can pick any shape you want. You can design your own. These are some of the common fin shapes. And then we also usually have like 3 or 4 fins. So you want to kind of space them out and make it symmetric. But if you want to, you can do even more than that. This is just like the suggestion. So this is how we're going to be attaching the fins. So there's a couple of ways to do it. If you looked at the document I sent to the chat, that explains a different way to do it. That I think is easier if you only have glue and you don't have tape. But if you do have tape, I think this is kind of the fastest way to do it. So basically you want to cut out the shape of your fin that you want. So here you can see I wanted a triangle. So I cut out a triangle right here. And then I ripped 2 pieces of tape that were roughly the same length. And what I did was I put the tape like halfway onto my triangle so that I could then stick it onto my rocket. And then I just kind of flipped that over and put tape on the other side so that it would stick out. And that's how I attached my fin. And then I just trimmed off extra tape. And then I did that on this rocket, I had 3 fins. But I know it's kind of complicated, so I'm gonna put it back to Devanshi to show you guys how to do that.
Hi, we're back. You guys probably don't have your fins cut out. I cut them out beforehand because I knew I'd be showing this to you. But basically, it doesn't really matter what shape or how many you make. I decided on triangles and I decided to do 3, but you don't have to do that. You could do squares, you could do like weird circles, you could do trapezoids, and then you could have like 4 fins if you wanted. But this is just what I'm doing. So try to make sure that they're like the same shape. You can like cut one out and then trace the others and cut them out over that. That's kind of what I did, so that you get, you know, similar looking little guys. So how I've been attaching them is you put tape on one side of the fin, and then you're going to tape that to the body tube. Don't like smack it down because you want the fins to kind of stand up. So once you have it taped down on one side, get another piece of tape and tape down the other side so that your fin kind of stands up away from the body. So it would look kind of like this. And now your fin kind of stands up. It's not like flattened against the rocket. And you're gonna have some extra tape on the sides that you can cut. Also, if I ever go out of frame, please let me know, because I'm trying to look on 2 different monitors to see if I'm in frame. And it's a very interesting experience. But yeah, now I've got the excess tape cut off, and here we go. And so this, basically, you just repeat this process for the other fins. I have 2 more. You guys might have 3 more. And try to space them out evenly. If you're doing 4 fins, make sure they're kind of, you know, they do that cross thing. If you're doing 3, make sure it's like 1 and then, you know, these 2. So yeah, just make sure that your spacing is as good as possible, because that'll definitely help it fly a little better. And yeah, just get to taping. I'll do it with you because I also have to make one.
Yeah, so if anyone has any questions, you can just raise your hand, and I will try to get to you also to help you guys out, because I know this part's kind of difficult. So if you have any questions, you can just raise your hand or use the raise hand function. So if you just want to follow along, you can just look at Devanshi's screen because she's taping on the fins right now. Is anyone having any trouble with attaching the fins? I know it takes a bit of time, so you can take your time. But if anyone needs help, please just raise your hand, or you can use the raise hand function, or you can type in the chat and I'll help you out. So I still don't see anyone. It seems like you guys seem to be doing great, which is very impressive, because I think this is the hardest part. You guys are crushing it. Has anyone finished putting the fins on a rocket? Can I get hands raised or a showing of a rocket if you finished it? Oh, impressive over there. I see that rocket. Is that purple, I think? That's cool. Okay, Annabelle. Really love the pink color. Jenny. Okay, nice. Loving this. Okay, cool. So I'm sure some of you guys might still be working on taping the fins on, and that's totally fine. And if you need any help with that, just let me know. You can type in the chat. You can raise your hand, ask a question. Is there a question from Madeline? Ron, do you want to unmute and let me know what you have?
I just finished rocket, so
Okay, cool. Thank you. Yeah. Okay, then I think that's a good sign that we can continue on and I can show you guys how to launch it. But if you are having any troubles, again, just let me know or send it in the chat and someone will help you. But I do want to move on for those of you who have finished your rocket, because it seems like it's a lot of you. So now we're going to be launching them. This is a really cool video of me launching it in slow motion. But basically, you're just going to take a straw, and then you're going to put your rocket on it. And then if you just blow on the straw, it should launch the rocket. And it's as easy as that. So make sure you take your rocket off the pencil and then just put it on your straw and try launching it. And let me know how that goes.
Looks like Clara's got it, and see a few
Ooh.
other people. Jenny's trying.
Yeah, if anyone wants to show their rocket, like unmute and show your rocket, or like launch it. Okay, wow, yeah, I see we're launching into the camera. It's getting dangerous out here. If anyone like wants to show me your rocket, that'd be really cool also. I think I saw a hand raised by Annabelle. If you want to unmute, or yeah, you want to unmute and show me your rocket? Ooh, cool. Nice. Yeah,
Wow.
so you guys can launch them horizontally like I did in the video, but you could also try launching it vertically too, because I mean, that's how we launch our rockets, right? And you can see where that goes and how high it goes. Yeah, so that's pretty cool. So I'm glad you guys are launching your rockets. I'm very excited that this is all working out. I hope it's super fun. A couple things I did want to talk about. If you do kind of want to learn more about how different things on your rocket affect its flight, you could definitely add more fins, change. I'm gonna mute people. Oh, sorry. I think I just hit ask to unmute instead of mute. But anyways, so you can put different fin shapes. You can make them bigger, you can make them smaller. You could add different stuff to your rocket and just see how it changes the path of flight of your rocket. One cool thing I kind of want to share with you guys is a change I made to one of my rockets. So I took one of my rockets here and I added these little flaps on the side. And what those do is that they cause drag on the rocket. So drag is, again, kind of a confusing word. It's confusing to me, and I'm learning about it in college. But basically, the way I would think about it is if any of you have ever like been outside running against the wind and you feel like the wind is like pushing back on you, that's kind of the same thing for a rocket. You know, the rocket's going really, really fast through the air and the wind is kind of pushing back on the surfaces. And here, because I added these little flaps on the side that aren't, it's not streamlined, the air is going to be pushing down on those. Versus if I didn't have them, the air wouldn't be pushing down on them, right? So I added these two little flaps and you can see how the rocket changes when I launched it. So this is what it looked like before I added the flaps. So you can see it pretty much goes all the way to the top. And then I added these little flaps and you can see it didn't go up nearly as much. And that's because of the forces acting on it. So that's just kind of like a cool thing. You can experiment with that or other things in your free time. So one other thing I want to talk about is the center of gravity. So we talked about gravity earlier, but basically you can find the point that we can say gravity is acting on your rocket by trying to balance it on your finger. So try to balance your rocket that you made on your finger. And once you get it balanced, mine's not super balanced, but once you do get it balanced, that's the point that is the center of gravity. So that's where the center of gravity is acting on your rocket. And then there's also like a center of pressure, which I think is a kind of confusing to explain. So I'm not going to go into it, but basically where those two things are in relation to each other affects how the rocket flies and if it flies well or not. And that's like a key thing for the aerodynamics of a rocket. So that's about center of gravity. Does anyone have any questions about anything I just talked about right now? Okay, we have a lot of questions. I'll take Clara's question first. Clara, do you want to unmute? Sorry. You want to unmute and ask me your question? I can't hear you.
What length would your rocket be?
Like what like these ones, the ones we made, or like a rocket from like that I showed you earlier, like the big rocket?
The bigger rocket.
Oh yeah, so the bigger rocket I showed earlier, well, it's almost as tall as I am, to be honest. And I'm about 5'8". I would say it's a little over 4 feet tall. So it's probably just as tall, if not taller, than some of you guys. We've built a lot bigger rockets than this. We've also built smaller rockets. And obviously the ones launched by like NASA and SpaceX are huge because people are inside those going to space. But that's how tall this one is. It's on the ground right next to me, and it's pretty tall. Other questions? Anyone have any other questions? April, what's up? You want to unmute and tell me?
So I am the hidden step now, but I forgot how to do it because the pointing thingy step took too long.
Okay, so you said you do have the fins on it, or you don't?
I don't have the fins on it yet.
Okay, so I sent something to the chat earlier. It was a document file in the chat. It's called Rocket Surgery .docx, I believe. And that is basically a guide on how to do this. So we're running out of time right now. But if you want to take a look at that later, if you want to like find it in the chat, it's like a how-to guide on how to build it. So you can finish building it on your own even after we end this, or so you can make more. So if everyone wants to check that out, that's in the chat. I can send it again because I think I sent it a little bit ago. But for right now, do we have any other questions? I don't think we have.
I think
any
everyone's
other.
just having a lot of fun with
Yeah,
the launching rocket.
Me too. Well, on that note, I just have one more slide then. And it's also kind of a fun slide. I just want to talk a little bit about engineering. So I'm sure some of you guys ran into this problem, but maybe your rocket didn't fly as nicely or as far as you would want it to, or maybe your nose cone wasn't scrunched up perfectly. And all those little things do affect like how your rocket's gonna fly. But the whole idea of engineering is not that you build the perfect rocket like the first time you build it ever. Like that's not what we do. Engineers pretty much just make mistakes and then we try to fix them. And that's pretty much our whole job. So the best way you can learn from this kind of stuff isn't just if you make a really cool rocket that launches, but if your rocket maybe falls or curves to the side a bunch or something, just going back and working on your rocket and trying to change things on it to make it fly better. That's exactly what we do as aerospace engineers. And so that's kind of what we do for aerospace engineering. We work on like the planes and rockets and stuff, and make sure everything works properly and that people can be transported safely on them. So I just kind of wanted to end on that note. Because I know I was building the construction paper rockets and I had difficulties with it. And I saw that my rocket would go to the side when I didn't want it to. And it's all about kind of tweaking your design to make it do different things. And that's the best way you can learn about the different properties of these rockets. Yeah, Porter, yeah. I feel that, yeah. I had some uneven fins on one of my rockets and it was very obvious, but I built 3 of them, so you can keep building these after. You could probably scale this up, I assume also. I just kept mine small, but when I added these little flaps, that's just because I was curious and wanted to see how it changed things. So definitely if you want to learn about how things affect like a rocket's like flight, instead of just Googling it, you now have a rocket and you can see how that changes the flight, and that's really cool and fun. So that's pretty much the end of the presentation right now. Does anyone have any questions? So you can like
Nope.
raise your hand if you do. Nope. Okay, I got one nope. Does anyone have any questions? You can raise your hand, or you can use the raise hand function if anyone does. I don't think I see any right now. Is there anything in the chat? Okay, I think Liam's saying bye. Goodbye, Liam. Yeah, so it is 5 p.m. So we're gonna be wrapping up right now. So that's pretty much the end of my presentation, or our presentation, my bad. And it seems like you guys don't have any questions, but I'll stick around for a little bit. If you do have like any questions, maybe about your rocket and how we can make it fly better. But other than that, thank you guys so much for coming. I'm very excited that you're all able to be here today. And thank you to the rest of my team for helping out with this. Just some like important things to remember is that to watch the hybrid video from earlier, the link was in the chat. You should also have that link otherwise from an email. And also, if you wanted to have the guide on how to build the rockets we just did, that's also in the chat. And I'll just send that again right now to make sure that you guys have it if you did want to, just so you could refer back to it if you forget. So yeah, that's pretty much it. That's all from me.
Thank you.
Thank you so much. Bye.
What's the difference between a rocket and a bee?
We're leaving.
Okay, bye. A rocket and a what?
A bee.
A bee? Oh, that's a great question. So, I mean, both of them fly, which is pretty cool, right? But rockets are things like we make, on Earth. It's human made, right? And we have engines that propel them, and that engine that's propelling it is going to stop at a certain point, and it's not going to keep going up. But a bee has its little wings, and it uses those to flap and like keep itself up. So there's a lot of differences. If anyone else wants to contribute some more, but those are like the main things I could think of. But I mean, they definitely do fly, both of them. But a rocket is less of a like gentle cruising flight and more of a trying to get to a destination, versus bees kind of fly around doing their thing. But bees have their own like aerodynamic properties that help them fly, which is really cool also. So it does all relate. So great question. Does anyone else have any other questions? I forgot how, I think I don't know. I know it started with a P. But your name on here is Sai. Okay, yes. Ptolemy, yes. So what's your question?
So I don't know how to shoot this right in here. Triangle.
Okay. Wait. Oh, so try sticking the. Wait, are you trying to figure out how to stick the straw into it?
And I can put it like.
Yeah. So there should be two ends to your rocket, and one is closed up because it's the nose cone, but the other side should be open. There should be one side of your rocket that's open, and you can stick the straw into that side, and you should be able to stick your rocket onto it and blow, and then it should launch it. Maybe your rocket is like a little too narrow, so I don't know if you can't fit it on the straw. Is your rocket on the straw? Looks like it is. So you should, yeah. If as long as the top of the rocket is closed and the bottom is open and it fits onto the straw, if you blow on the straw, it should launch. Yeah. Hopefully that helps. Does anyone else have any other questions? Although sometimes mine gets stuck, I will say. I have to kind of move it around. There we go. Okay. If anyone else doesn't have questions, then I think we'll probably end the meeting for now. So thank you guys so much for coming. It was really exciting to see your rockets. And yeah, you can always do that too. And I sent the guide so you can open that up and work on it later also if you want. But yeah, thank you so much for coming. I hope you enjoyed learning about rockets. April, do you have a
It
question?
looks like April has a question. Yeah.
Oh, is that your rocket? I like it. Have you tried launching it?
No, but it didn't go as far as I.
Did it go off of the straw at least? Like, did it fall off when you blew on it? Yeah. Yeah. Yeah, sometimes that's kind of why I had the part where I talked about how it's really hard to make it fly perfectly at first, but you can keep making new rockets and to make it launch like even better every single time. Yeah. Thank you so much for sharing though. Okay. I think we are good then to go. If no one else has any other questions, then I will end the meeting. It was really nice to meet all of you, and I hope to see you guys tomorrow also at Illinois Space Week. All right, oh, did you make a rocket into a bird? That's fun. Wow, not into a bird, but it looks kind of like a bird from the angle I saw. I see you just added more fins though. That's really cool. Yeah, exactly. Keep adding stuff. See how it changes the path of flight. Very cool stuff. Very impressive. All right. Okay, I'm gonna end the meeting. Thank you guys so much for coming. Bye.